Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the Information Disclosure module titled Authentication Bypass via Information Disclosure. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on information, disclosure vulnerabilities, and select lab number 4 titled Authentication Bypass via Information Disclosure. Alright, let's get started. This lab's administration interface has an authentication bypass vulnerability, but it is impractical to exploit without knowledge of a custom HTTP header used by the front end. To solve the lab, obtain the header name, then use it to bypass the lab's authentication, access the admin interface, and delete Carlos's account. You can log into your own account using the following credentials. Alright, so the idea over here is that we have a custom HTTP header that we need to identify, and then that custom HTTP header will allow us to bypass the lab's authentication, gain access to the admin interface, and then delete the Carlos user. So let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already getting passed through my Burp proxy. Okay, so let's click on view details first of all, and you could see over here, it's a get method to product ID. Let's send this to repeater. And then from there, let's see if it allows for the trace method, which is usually used for debugging purposes. Now, the thing with the trace method is that it should never be enabled in production because it does leak potentially sensitive information to the front end. So you could see over here, there is a bunch of headers that are used, and one of the headers is called X Custom IP Authorization. So this is definitely a custom header that I've never heard of before. And what it does is it looks like it takes in the IP address of the user. Now over here, I have my IP address blacked out because that shouldn't be visible. But the idea over here is that the application will trust the IP address localhost because it'll view it as coming locally from the same server that the application is installed on. And so that's the way we're going to exploit the vulnerability. So let's copy this and send this to repeater. Now in repeater, we'll add the header right over here. And instead of having our public IP address, we'll say 127.0.0.1 and then hit send. It's a 200 OK message. Let's see if we can see the admin page. And we cannot, but can we see the My Account page? And we also cannot. That's weird. Okay, and the reason is because we're still using the trace method. So let's make this get, hit send, and let's look again for the admin interface. You could see over here now it's giving you unfettered access to the application because it thinks you're coming locally from the server where the application is installed on. So we have the admin panel. Let's visit that. So let's say /admin, hit send. And if we go down over here, the admin panel should have the ability to delete users. And here we go. So in order to delete the Carlos user, it's this link over here. In order to delete the user that we were given, it's this link over here. So all we have to do is copy this and perform again the same GET request with the customized header. Hit send. And you get a 302. If you follow the redirection, you'll get to this page where it says, congratulations, you solved the exercise. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Okay, so now before we script it, one thing to note over here is we didn't even have to log in with the credentials that we were given. That's how bad this vulnerability is. It relies on a customized header and it assumes that you might not know this header, and it allows you unfettered access to the application. Now, this is still a vulnerability. Whether it leaks this header or not, it shouldn't trust client-side input in order to perform access control decisions in the backend. And so there's really two vulnerabilities over here. The fact that trace is enabled, and then the second one is that it relies on a header to perform access control decisions. All right, let's import the libraries that we need. So the requests library, the sys library, the URL lib3 library, and the regex library. Next, let's disable insecure requests warnings. So URL lib3 dot exceptions dot insecure request warning. And then let's set our proxy setting because we want all of our requests to be sent to burp. So all of HTTP traffic should be sent to HTTP 127.0.0.1 port 8080. That's where burp is running. Same goes for all HTTP traffic. It should be sent to HTTP 127.0.0.1 port 8080. Let's save that and click on view word wrap so that it all appears to us in one page. All right, next let's define the main method. So if name is equal to main, then call the main method, and we'll define the main method right over here. So if the length of the command line arguments is not equal to 2, then print the usage instructions. So %s URL, and that's taken from the command line argument. And then we'll also print example instructions. So example, name of the program, and then an example URL, so www.example.com. And again, the name of the program is taken from the command line argument. And we exit the program because the user ran it incorrectly. Now let's assume the user did run it correctly. The first thing we're going to do is create a sessions object. So request.session. And then we're going to say URL is equal to sys.argv1. So we're taking the URL from the command line argument. And then we're going to call a function called delete Carlos, which deletes the Carlos user. And that's a custom function that we'll define right over here. So def delete Carlos takes in the session object and the URL. Now for delete Carlos URL, that's a variable that is equal to the vulnerable URL. So that would be the URL of the application plus this path right over here. Let's copy that. And then we're going to set our headers. So we're going to say headers is equal to the custom header that we included and we used in order to bypass authentication. So we're going to copy the whole thing. And let's take all of this out, add a colon and put it in here and remove the colon from over here. All right, this looks good. Now all's left to do is to perform the request. So s.get because it's a get method. It takes in the URL, delete Carlos URL. Headers is equal to the headers that we just defined, and we're missing an s over here. And then verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want the request to be sent to burp. Now we're going to confirm this worked by checking for the message congratulations in the response, so r.text. If we get it, then we're going to print successfully deleted Carlos user. Otherwise, we're going to print could not delete user, and we'll exit the program. Let's save it. This looks good. Let's make this bigger. Go to terminal, new terminal, Python 3, name of the program, and then the URL of the application. Now this might have timed out, and it did, so let's open a new instance of the lab. Let's copy it, put it in here, and remove the trailing slash and hit enter. And here we go. It says it successfully deleted the Carlos user, and you could see over here it says congratulations, you solved the lab. Alright, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of an information disclosure vulnerability.